All right, what we're going to do today, we're going to stick with right triangles. And let's put a right triangle in here, and we're going to see something that should be very familiar to you. I'll call that side A, this side B, and this side C. Now, this is a right triangle. This whole chapter is about right triangles. Now, we have a little formula, okay? A little theorem is a big hint. A theorem that relates A, B, and C with right triangles. Anybody remember what it was? Pythagorean Theorem. Very good. Let's write that up here. Okay, Pythagorean Theorem. The rest of this lesson is going to have to be kind of no nonsense because we talked a little too much about the Khan Academy stuff, right? So Pythagorean Theorem, named after a man named Pythagoras a long time ago. We won't get into that. And what did it say? It said that a squared plus b squared equals c squared. Does that work with any triangle in the world? No, only with right triangles, okay? It only works with right triangles. Make sure that you realize that. Don't try to use that with an acute triangle or an obtuse triangle. It only works with a right triangle. What about the A and the B? What did the A and the B represent on this right triangle? The legs of the right triangle. And then the C has to represent what? The hypotenuse. The hypotenuse, we talked about that in the last lesson. Hypotenuse is the side that's opposite the right angle. So the C has to be the hypotenuse. The one that's by itself, everybody see that? The one that's not being added to the other thing, that's always has to be a hypotenuse. I mean, you could use other letters. It doesn't have to be A, B, and C. But the two legs, what they say, sometimes they say this in a long way. Did they ever talk about what's that Dorothy, Wizard of Oz? That's what it is. Okay, on Wizard of Oz, who's the guy that needed the brain? The Scarecrow, right? The Scarecrow needed the brain, right? So when he gets the brain, right, or he gets the diploma, right? You remember that? Gets the diploma that said he's real smart or something. As soon as he got it, he said something to the fact of the sum of the squares of the two legs of a right triangle equals the square of the hypotenuse. And he said it really fast. We're not going to do it today because there's no nonsense date right now because of time. But he actually says it kind of incorrectly, and he's trying to say Pythagorean Theorem. So even back then, I think it was like 1939 they made that movie. They were doing Pythagorean Theorem, okay? And he said the sum of the squares of the two legs of a right triangle equals what? The square of the hypotenuse, all right? And that's what he said to make it look like he was really smart. He quoted Pythagorean Theorem. All right, so that's just a little interesting tidbit. And he actually didn't say it quite right, though. That's what's more interesting about it. All right, enough of that. Let's do a quick example. What if I give you a right triangle right here, and I said that this is 3 and this is 4, and then I asked you to solve for C. All right, let's do that very quickly. So remember, it's a squared plus b squared. It's the two legs. It's the sum of the squares of the two legs. That means I'm going to square both legs and add them up. That's what it means by saying the sum of the squares of the two legs. And that equals the hypotenuse squared, which is c squared. Let's add this up. That's 9, and that's 16 equals c squared. 9 plus 16 is 25, and that equals c squared. We did this all last lesson. What do we do to get c by itself? Take the square root of both sides. Do we just leave it the square root of 25? No, not if it comes out even. Not if it's a perfect square. It's a perfect square if you take the square root and it comes out to a nice whole number. So c is what? 5. All right. So that's kind of nice, isn't it? It's not always going to come out to a nice even number, though. All right. Don't get used to that. In fact, it happens so few times that they have special triangles, okay? And they call these special triangles Pythagorean triples. And these are very, very helpful. They can be very, very helpful to you. Because if you're going to take the SAT or something like that, you need to do things quickly because they time the test. You have to finish in a certain amount of time. And if you don't, you have to go on to the next section. You can't answer those questions. So they will give you some questions on the SAT where it really is helpful. You don't have to know them, but it's very, very helpful to know the Pythagorean triples. The first one is this one. It's 3, 4, 5. That means if one leg is 3, the other leg is 4, the hypotenuse is going to be 5. What if I did this? What if I said this was 6 and this was 8? Just really quickly, without going through the whole Pythagorean theorem, what do you think the hypotenuse is going to be? It's going to be 10. Very good. Because what did we do? We just took the 3 and we doubled it, right? Took the 4 and we doubled it. So we would take what? The 5 and double that. See how nice and easy that is? Okay, so that becomes very, very helpful knowing 3, 4, 5. There's another Pythagorean triple. 5, 12, 13 is another Pythagorean triple. Now I'm trying to remember the other ones off the top of my head, and I can't. There's a whole chart on page 542, and it lists some of the common Pythagorean triples. Not all of them. You can't really list them all. I think there's probably an infinite number, but here's some common ones. 3, 4, 5 is one, 5, 12, 13, 8, 15, 17, and then 7, 24, 25. And what does that mean, and why is that helpful to us? Because if I had a triangle, watch this. Knowing these, if you have these things memorized, it saves you a little bit of work. So let's say you had a right triangle. Let's say this is 8 and that's 17, and you had to find that side right there. What would you do to find this side right here? You could do Pythagorean theorem, couldn't you? All right. Or you could remember your Pythagorean triples. If you remember your Pythagorean triples, the two legs would be 8 and 15, and the hypotenuse would be 17. Look, I got one leg is 8, the hypotenuse is 17, so what does the other leg have to be? It's got to be 15. Isn't that nice? So if you know those triples, it really, really helps you. All right? You don't have to. You could have always done this. Watch. Let's do this without knowing it was a Pythagorean triple. Is that all right? So let's pretend we didn't know it's 15. Let's just pretend. But we'd still know how to do Pythagorean theorem. So let's do Pythagorean theorem. So how would I do that? I go 8 squared plus what? X squared. You know what a lot of people do? I'm not going to write it down because I don't want you to see it. But what do you think a lot of people do? They go 8 squared plus 17 squared. But remember, the hypotenuse has to be the one that's by itself. Don't do that. Make sure you take the two legs, square them, add them up. Everybody see that? So don't just take the two numbers that you see, that you know, and square them and add them up. You got to take the two legs. It's very important. In fact, it's always going to be the two shorter sides. How do you know they're going to be the two shorter sides? Well, because the hypotenuse is always the what? Well, I'm talking shorter and longer. Look, because the hypotenuse is always the longest side, isn't it? Okay? So the ones that I add together will always be the two shorter ones. The one that's sitting there by itself is always the longest one. Make sense? Okay. So watch this. 8 squared is what? 64? I should know that. Is that 289? I think it's 289, isn't it? Subtract 64 from both sides, and we get x squared equals 225. Take the square root of that. If I put that in my calculator, the square root of 225, guess what? It's 15. So I could have done all that, right, to get that side right there, but wouldn't it have been really nice to just have that thing memorized? Absolutely. Okay? Now, they're not always going to come out to nice whole numbers like this. They could come out to ugly numbers. So let me just do one really quick that comes out kind of ugly. And I don't know, I'm just making these up. Let's say that's 7, and this is 29. All right, and let's say this is x. All right, so let's solve for x. This is not one of our Pythagorean triples. So I just have to do Pythagorean. You need to do that's right triangle. I'm going to do Pythagorean theorem. So watch what I'm going to do. I'm going to go 7 squared plus x squared equals 29 squared. Okay? And this is what? 49 plus x squared equals, I have no idea what 29 squared is. Let's try that. 29 squared is 841, okay? Subtract 49 from both sides. Subtract 49. So x squared equals 841 minus, what, 49? Should be able to do that in my head, but I'm not going to. 792 And what do? Take the square root, and I'm perfectly fine if you leave it the square root of 792. I know you don't like that. I know it looks a little ugly, but I'm fine with that, okay? I'm fine with you leaving it like that. You know, for now anyway. So let's do the square root of 7. Watch this. Let's just see. Now, don't do this on your homework. I don't really want to see a decimal, but I'm just interested. It's around 28. Does it look like this side could be around 28? Absolutely. It's smaller than 29, right? It's not really drawn to scale because 7 should be like really, really small if this was 28. But you get the idea. Yeah, it definitely looks right. Let me do something really quick. Here's a way to tell if you have a right triangle or not. Actually, let's do it this way. If you take the longest side and square it, if it's equal to this, then it's a right triangle. So what they're going to do is they're going to give you 3 sides. They're going to give you 3 numbers, and you have to determine if it's a right triangle, if it's acute, or if it's obtuse. Now watch this. What if c squared was less than a squared plus b squared? If I took the longest side and I squared it, and it was less than these 2 things squared and added up, it would be an acute triangle. You're right. And guess what the other one is? If c squared was what? Greater than a squared plus b squared, then what kind of a triangle would it be? It would be an obtuse triangle. All right? So if they gave you time's running out. I want to find the example they give you. Okay, what if they gave you, where is it? Okay, what if they gave you this? 7, 15, and 21. And they asked you, what kind of a triangle is that? Is it right, acute, or obtuse? What would you do? Take the longest side and square it first. Which one's the longest side? 21. And then I'm going to compare it. I'm going to put a question mark there because I don't know if it's equal, less than, or greater than. Then what I'm going to compare it to? 7 squared plus 15 squared. And let's use a calculator and see what we get. All right, so 21 squared is 441. All right, and let's do the other ones. 7 squared, that's 49. I know that already. Plus 15, that's 225, but I'll square it anyway. Okay, and that equals 274. All right, so that's 274. It's a weird 2. So 441 is what? Greater than 274. So what kind of a triangle is this thing right here? It's obtuse. That's all you have to do. It's pretty easy, isn't it? All right, right on time. Let me give you a worksheet before you go, and that's your homework.